So now that we've come up with our definitions for our inverse trig functions, inverse sine, inverse cosine, and inverse tangent, here we're going to talk about evaluating inverse trig functions, okay? Now, much of the work with inverse trig functions involves exact values rather than calculator approximations, and can often be related directly to the unit circle, okay? Unlike our standard trigonometric functions where we plugged in angle measures, for example, we evaluated sine of an angle, cosine of an angle, tangent of an angle, and got out a number, with inverse trig functions, we can think about our inputs as being our domain, that's as being numbers, and our outputs or range as being angles. So you might recall from the last video, we talked explicitly about the domain and the range of each one of those inverse trig functions. It is very, very critical that you pay careful attention to the ranges in particular of each of those inverse trig functions, because that is where our outputs are going to be between always. We're going to talk more about that coming up. So with regular trig functions, we plugged in an angle, we got out a number. Okay, for example, if I asked you to evaluate the sine of pi over 4, we plugged in the angle pi over 4, and you guys know by now, to evaluate sine of an angle on our unit circle, we find the angle, sine corresponds to the y-coordinate, our answer is root 2 over 2. Plug in an angle, get out a number. Or if I asked you to evaluate the cosine of pi over 6, we'd find the angle pi over 6 on the unit circle, cosine corresponds to its x-coordinate, that would be root 3 over 2. Again, we plugged in an angle, we got out a number. Or for tangent, the tangent of pi over 3, well, we'd find the angle pi over 3. Tangent is the ratio of the y-coordinate divided by the x-coordinate. That would be root 3 over 2 divided by 1/2. That's the same thing as root 3 over 2 times 2, giving us root 3 as our answer. So regular trig functions, we plugged in angles, we got out numbers. For inverse trig functions, we have the inverse of that. We plug in a number, and we are going to get out an angle. So our range, our outputs, we can think of those as being angles. For example, if I ask you to find the inverse sine of root 2 over 2, this is going to be the angle that has a sine value of root 2 over 2. Well, take a look at what we saw up here. The answer, in this case, is going to be pi over 4. All right, just think about what you know in terms of inverses, right? We're basically reversing this entire process. Okay, the inverse sine of root 2 over 2 is pi over 4. Notice we plug in a number into our inverse trig function, and we get out an angle measure. Inverse cosine of root 3 over 2. This is an angle that has a cosine value of root 3 over 2. Our answer in this case is going to be pi over 6. We plug in a number, we get out an angle. The inverse tangent of root 3, the angle that has a tangent value of root 3. Well, that's going to be the angle pi over 3. So whenever you guys are evaluating inverse trig functions, recognize that you should be thinking about getting an angle out. Inverse trig functions give us angles. As I mentioned before, it's incredibly important here to know and understand the range of each inverse trig function, as these will determine the correct angle measure that we are going to get. All right, so when we studied inverse sine, this was the graph of our inverse sine function. The domain was -1 to 1. The range was from negative pi over 2 to positive pi over 2. So that means our angle measures that we are going to get out have to be between negative pi over 2 and positive pi over 2, meaning it's either going to be in the first quadrant or in our fourth quadrant. And notice that I have also drawn all of these angles in as negative angles. And the reason being is when I say our answers that we get out have to be between negative pi over 2 and positive pi over 2, you should also consider what this might look like on a number line. Okay, if I have 0 here, and I've got pi over 2 here, and negative pi over 2 here, all right, I should only get angles that are between these two values. Sorry, not drawn out so well. All right, but I should only get angles that are in between these numbers. If I'm getting an angle that's beyond one of these numbers, we're not doing inverse trig correctly, right? I could never get an answer that was, say, pi, for example, right? Pi would be all the way out here on the unit circle, right? Not going to work for inverse sine. Okay, so there is our range for inverse sine. What about inverse cosine? Well, here's the graph of inverse cosine that we came up with. And we said the domain was from -1 to 1, and our range was from 0 to pi. Well, in terms of the unit circle, that means all of my outputs, all of the angles that I get out, have to be between 0 and pi for inverse cosine. Okay, that means, in terms of a number line, here's 0, here's pi. If I get anything that's other than numbers between 0 and pi out, I'm doing something wrong. Okay, I could never get an answer for inverse cosine that would be maybe 3 pi over 2. Right, 3 pi over 2 would be way out here on the units, or on my number line here. Okay, I only get out angles between 0 and pi. For inverse tangent, our range was from negative pi over 2 to positive pi over 2. So in terms of our unit circle, that's going to correspond to the first and fourth quadrants, right? So this looks very similar to inverse sine, okay? Except notice that the endpoints at negative pi over 2 and positive pi over 2 are open. They are not included because tangent is undefined at those values. All right, so let's see if we can't figure out how to evaluate some trig functions here. Inverse trig functions. Evaluate the following expression involving inverse trig. I've kept this graph on the right-hand side for your reference because, again, think about where the angles are coming from that you are going to get out. Okay, your outputs. Arc sine of 0. Remember, inverse trig. We plug in a number, we get out an angle. This is the angle that has a sine value of 0. Now, that angle has to be between negative pi over 2 and positive pi over 2. What angle between negative pi over 2 and positive pi over 2 has a sine of 0? Well, that's going to be the angle 0. 0 is our answer. Okay? Inverse cosine of 0. This is the angle that has a cosine value of 0. And that angle, because we're dealing with inverse cosine, has to be between 0 and pi. What angle between 0 and pi has a cosine value of 0? Pi over 2 is our answer, right? This is the angle that has a cosine of 0. We plug in a number, we get out an angle. Arctan of -1. This is saying what angle has a tangent value of -1. Again, we plug in a number, we get out an angle. And that angle must be between negative pi over 2 and positive pi over 2. That's our range for inverse tangent. Well, between negative pi over 2 and positive pi over 2, if the tangent value is -1, that means that the x and y coordinates must be opposite of each other, meaning our answer is negative pi over 4. Okay? Notice the correct answer is negative pi over 4. It would be an incorrect answer if you were to say that the answer was 7 pi over 4, right? 7 pi over 4 corresponds to the exact same location, terminating location, as negative pi over 4. Okay, all right, but 7 pi over 4, if you think about it on a number line, right? Again, here I have negative pi over 2, 0, pi over 2. On this number line, is 7 pi over 4 between negative pi over 2 and positive pi over 2? No, 7 pi over 4 would be way out in this region here to the right. Okay, so the correct answer is negative pi over 4. Inverse tangent of 0. This is the angle that has a tangent value of 0. That means when I take the y coordinate and divide by the x coordinate, I have to get 0. And again, that angle must be between negative pi over 2 and positive pi over 2. The answer, 0. Arc cosine of -1. This is the angle that has a cosine value of -1. Well, that angle has to be between 0 and pi, because I only get out angles between 0 and pi for inverse cosine. All right, and cosine corresponds to the x-coordinate. The angle that has an x-coordinate of -1 would be pi. Okay, arctan of √3. All right, this means that when we take y and divide by x, we have to get √3. And our range for inverse tangent is -pi/2 to +pi/2. We can rule out the fourth quadrant because we know the tangent value has to be positive. All right, and our only options with √3s in them are going to be pi/6 and pi/3. Now, notice that when I take y and divide by x, I have to get √3. Which angle gives me that? That is going to be pi/3. Arctan of √3 is pi/3. Inverse cosine of -1/2. This is the angle that has a cosine value of -1/2. Well, here's inverse cosine. Between 0 and pi are my outputs. I know that the cosine value is negative, therefore I must be in the second quadrant. Which angle has a cosine value of -1/2? That's going to be 2 pi/3. Inverse sine of -√3/2. This is the angle that has a sine value of -√3/2. Well, here's my inverse sine range, my outputs for inverse sine. It's got to be negative, so that leaves us with the fourth quadrant, right? And I have to have a y-coordinate of -√3/2. That's going to be -pi/3. All right, inverse sine of -√2/2, arc sine. Remember, inverse sine, arc sine mean the exact same thing, okay? Two different notations. Arc sine is negative. I've got to be in the fourth quadrant. Which angle here in the fourth quadrant has a sine value of -√2/2? That's going to be -pi/4. All right, one last one here. Arctangent of -√3 divided by 3. Well, our range for inverse tangent is from -pi/2 to pi/2. The tangent value is negative, meaning I have to be one of these angles that's in the fourth quadrant. And when I take y and divide by x, the y-coordinate, and divide by the x-coordinate, I have to get -√3/3. Okay, all right, our answer in this case is going to be -pi/6. And you can always just double check that to make sure, right? We definitely are able to narrow it down between -pi/6 and -pi/3, but just think about the coordinates that we have here, right? This would be the ordered pair √3/2, -1/2. When I take y, -1/2, and divide it by x, √3/2, well, that's the same thing as -1/2 times 2/√3. 2's cancel out. We get -1/√3, which we then rationalize into -√3/3. Okay, we want the angle that has a tangent value of -√3/3. That's -pi/6. Okay, so there you have it, evaluating inverse trig functions using the unit circle. Again, the unit circle is so important here, guys. All right, and again, pay very, very careful attention to the range of each one of those inverse trig functions. Inverse trig, plug in a number, get out an angle.